So example number 2, related to calculating delta S for a reaction. So next up I've got CaOH by 2 as a solid plus 2 HCl's aqueous, making 2 H2O's as a liquid plus CaCl2 aqueous. So there's a balanced chemical reaction, and we're going to calculate delta S for that reaction. So we need the individual enthalpy values for each substance. We look them up in the table. We flip to the back of the book. If you're not using our book, every UChem book will have them. You can also find some entropy and enthalpy tables online, but they're a little bit harder to come by because they're multiple page tables. So you might want to hit up the library or something like that if you don't have a textbook and look at a big table of delta H values and delta S values. For what we're doing, I'm going to do my best to always give you the values in case you don't have the option of looking them up. Okay? So for our equation here, delta S for calcium hydroxide is 76.1, HCl is 56.5, H2O as a liquid is 69.96, CaCl2 is 114. And this is joules per mole Kelvin. So delta S for the reaction would be, go to the product side, 2 times 69.96 plus 1 times 114 minus, go to the reactant side, 1 times 76.1 plus 2 times 56.5. This is in joules per mole Kelvin once we calculate it. So we're ready to run those numbers through. 2 times 69.96 plus 114. I have 253.92 on my screen. Now minus 76.1 minus 2 times 56.5. Let me run that through a second time. 2 times 69.96 plus 114 minus 76.1 minus 2 times 56.5. Okay, 64.82 is what I have shown on my screen. So plus 64.82 joules per mole Kelvin. So this problem didn't look much different than the other ones. We just had different numbers and different coefficients. That's really all that changed on all of our enthalpy calculations last semester. It was different reactions, different coefficients, but it's always products minus reactants. So is this one. All right, I got one more to show you. That's in our next video.